Okay, today, talk about polygons. And so our common core is really G for geometry, CO for congruence, and it's number 11. And it stands for prove theorems about polygons. Okay? So let's first of all, number one, just define it. Well, the first one's that's not a polygon. It can't be. I mean, because first of all, it's like two different figures, right? And it's got this curved line. So it's not a polygon at all. I mean, polygons are many-sided figures, but the sides have to be straight lines or line segments, okay? This is a polygon, but it's a concave because it got caved in, right? That's a concave one. That's a convex polygon because all of it's like puffed out. There's no cave spots, right? And that's a regular polygon just simply because all the sides are equal. So you just go like that, that. All the sides are equal. And I can go like this, meaning this angle is equal to that angle, which 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 is equal to that angle, okay? All right? Now, let's do example 1. So find the sum of the interior angles. Okay, so here's our formula. S equals 180 times n minus 2. All we got to do is just go 180 times, let's see, there's 1, 2, 3, 4, 5, 6. So n is 6. So I'm just going to go 6 minus 2. That's all I'm going to do. Okay? Wyatt, I know you're paying attention. Of course you are. So it's just 180, 6 minus 2. It's the formula. Put 6 in for n and just use your calculator. I think you get 720, don't you? Yeah, 180 times 6 subtract 2, 720 degrees. That means if you were to add them all up, they'd all add up to 720 degrees. Easy? It's really pretty easy. Okay, number 2. It's a hexagon. Well, it's the exact same problem, isn't it? If it's a hexagon, then n is 6. Even though we don't have a figure, it's still going to be the same answer. Because if n is 6, it's a hexagon. We don't even need to draw it. Just go, okay, 180, 6 minus 2, which we just did that problem, 720 degrees. Okay? Okay, example 3. Well, let's see, we've got 1, 2, 3, 4, 5, 6 sides again, right? So I do know that if I had all the angles, they'd all add up to 720. Well, how do I know that? I just did that, right? We just did the hexagon. So this is a hexagon. And I know that if I were to add them all up, they'd have to add up to 720. So let's add them all up. So let's go x plus 22 plus x plus 22 plus 90 plus 90. So let's see if I do an x and I do plus an x plus 22 plus another x plus 22 plus 90 plus 90, right? And add them all up, okay? Let's see, x, that's 4x, right? Let's see, 22 and 22 is 44, 44 at 180, plus 224 has to equal the 720, right? So add all these up, and I know they add up to 720. How did I know it was 720? Because it's a hexagon, we just did that, right? So I know that they all add up to 720, so I add them all up. I got 4x plus 224. Now let's just solve. Minus 224, 720, minus 24. I got a 496 equals 4x, so I subtracted. I got 496. I'm going to divide by 4, and I get 124. Okay, now we're not done. That just tells me what x is. So let's go back into the figure, okay? So this angle then is 124 because that's x, right? And then this angle here is also 124 because that's x. So these two angles are going to just simply be 122 plus 124 plus 22. So it's 124 plus 22. 146 for that one. And 146 for that one. And of course those are 90, okay? Not bad. Just had to do a little bit of algebra. Pretty easy, okay? Okay, now, you ready? Kurtz Theorem. I like that. Call it Kurtz Theorem. So what does Kurtz Theorem says? Well, first of all, Kurt told us, didn't you, Kurt? Kurt said, well, first of all, Mr. Davies, it has to be regular, otherwise it won't work. Totally agree with you, Kurt. So central angles. I'm just going to draw them in because it's easier if we see them. You don't have to, but if I draw them in, you go, oh yeah, it makes a lot of sense. This is what Kurt saw, because Kurt's a mathematical genius, right, Kurt? Yeah. So here's what we do know. I mean, this makes sense. If you go all the way around a circle, you've got 360 degrees. Guys agree? And then because there's 1, 2, 3, 4, 5 sides, then there has to be 1, 2, 3, 4, 5 central angles. So if we just take my 360 and divide it by 5, we'll get each individual central angle. 72 degrees. Nice job, Kurt. But it has to be regular. This will not work unless it's regular. So I'm going to just make sure I highlight. It's got to be regular, okay? Make sure you highlight it, circle it, whatever. If it's not regular, it won't work, okay? Okay, example 6. This is the formula we had in our notes. So if you want an individual interior angle, okay, if you want to know exactly what that one is, it has to be regular. Because if it's not regular, then they're all kind of different, right? I mean, if I go and look at this one here, they were all different, weren't they? So I wouldn't be able to find out which, if they were individual unless I had more information. But if it is regular, I can find out exactly what that one is because all 6 of these are equal. So let's use our formula. So if I go 180 times 6 minus 2, that gives me 720 degrees. But that 720 degrees has to be divided up into all 6 of these, right? So since they're equal, just divide that by 6. We get each individual angle to be 120 degrees, okay? So it must be regular in order to find an individual interior angle. Thumbs up? Capiche? Okay. Super easy. Don't lose this sheet because when the next quiz comes up, you're going to need to know all of these formulas, right? And they're easy formulas, but if you forget them, then it's kind of hard to recreate them, okay? Turn the page. Okay, exterior angle. So again, I'm going to draw in my exterior angles. There's an exterior angle. That's an exterior angle. That's an exterior angle. That is, and that is, okay? So in this case, there's 5 of them. And so we just take our 360 degrees and all 5 of them together, they all have to make, if I add them all up, they're 360 degrees for the sum. That plus that plus that plus that plus that is 360, okay? Always 360, okay? Individually, if it's regular, we can just divide it to find out what they are individually, okay? Example 9. Am I going too fast? Okay. Okay, number 9. So let's check it out. 7x, 2x, 3x, 6x, 2x, right? Well, I do know if you add them all up, they're going to add up to 360 degrees. Okay, so let's add them up. 7x plus 2x is 9x. 9, 10, 11, 12. 12 and 6 is 18, 19, 20. So I've got 20x equals 360. Okay, you with me? I just add them all up. That plus that plus that plus that plus that makes 20x. So let's solve. Divide by 20, divide by 20. Should be 18, I bet. So x is 18, but that's not what each of the angles are, but that's easy because then we just plug it in, right? So if that's 18, let's plug it in and see what we get. Okay, so go 18 there, 18, 18 there, 18 there, 18 there. So I'm going to get 18 times 2. This one's 36. That one's 36, right? 18 times 3, I think is 54. Hold on. 18 times 3 is 18 times 3, 54. 18 times 6, 18 times 6, 108 for that one. And 7 times 18, 126. How's that? Pretty easy? Okay. Now, individual exterior angle. So first of all, it must be regular. So what I want, let's draw a picture. I want that angle there. Okay? I just want that angle there. Now, if it's regular, then I can find it because I can take, and I know that all of them are equal. So I know it's 360 no matter what. I just divide it by the number of sides. Okay? So I'm going to take my 360 and divide it by, let's see, that's an octagon, I think. One, looks like an octagon. Stop sign. 1, 2, 3, 4, 5, 6, 7, 8. So I take 360 divided by 8. I think is that 45? Pretty sure it's 45. 360 divided by 8. Yeah, it's 45. How's that? Easy? Okay, now number 12. Let's play Jeopardy.
What?
Yeah, let's play Jeopardy. You know, the thing about Jeopardy, Nicole, is they give you the answer and you have to find the question. So, where's my reading at? Where's that reading at? I got it around here somewhere. Let's see. Here's my reading. Here's my reading. Okay. So one of these figures has an individual interior angle of 150 degrees. Okay. So one of these figures. So which one? Name the figure of a regular polygon with an interior angle of 150. So what I'm going to do is I'm going to do it a little bit backwards. I'm going to go ahead and use my formula. So if I look, okay, regular polygon with interior angle. So regular polygon, individual interior angle. So I'm going to use this formula, okay? Regular polygon, individual interior angle. So I'm going to use this formula, okay? So I'm going to go, I know that my 150 is equal to this 180 times n minus 2 divided by n. So one of these figures, n would be the number of sides, whether it's an octagon or a pentagon or a septagon or who knows, one of these figures, the answer is going to be 150. So let's just back it up and solve. Okay, algebra kids, how do we solve for n? Multiply by n. Good choice. If I multiply by n, if I multiply up by n, times both sides by n, right, that'll undo the n. So the n comes up here. I have 150 n equals 180 times n minus 2. Okay, great. Now it gets easier, doesn't it? Doesn't it get a little bit easier now? So what's the next step?
Would it be 100? Why don't you? Yeah, do that.
Distribute. Let's distribute.
That's
That's the word you're looking for. Let's distribute, okay? 150 n equals, and I distribute 180 n minus 360, okay? And then, let's go minus 180 n minus 180 n gives me a negative 30 n equals negative 360, right? Divide by negative 30, and I get n equals 12. Okay, well, let me see. What is a 12-sided figure? It's a dodecagon, isn't it? So my figure is a dodecagon. Okay, here's our homework, page 386, 2 through 30 even, 66, and I think that's 60, I don't know. Which one is that one, real quick? Let me look. It got hole punched. 67. It's got to be because that was the last one. Okay.